Okay, we can start. We have a MacBook Air. I've already taken the board out of the shell. It's a 2017 board number is 820-00165. It starts, the fan rolls, but it doesn't, no display, it doesn't host, no keyboard function in terms of capsule. So basically, it doesn't have a brain. So this is a liquid damage device. As you can see, there's a bit of corrosion to the CPU. And then on the other side is also not looking. It's not so bad on the other side. So this here it looks like there was like a someone tried to reflow the RAM chips. We're not sure why that is. Nonetheless, so I did start to make measurements on the board already. I'm just gonna start, and there's something something that I noticed on the fan. So the way the fan is supposed to operate is when there is power on the board, the fan will start and then gradually increases, and then eventually the SMC will now step in to control the rotation of the fan. But what I noticed with this, immediately there's power on the board, the fan just goes 100% without any form of gradual increase. That is also an indication of an issue, because that's not the way the fan is supposed to operate. So I'm just going to test it again for you guys to see. So I connect my charger. Obviously, there will be no charger indication, and there will be no LED because we don't have our IO cable. So you see the fan goes 100% immediately, and there's nothing on the screen. So what I did notice is when I started to make measurements on the board, there's a particular cap that looks funny. This one here, that doesn't look good. Now, let's see what that cap, so this is 80-00165. Let's see what that cap is. So this is a cap that looks funny. So that the the, the C1212 looks funny on the rail. So what we want to do is we are going to remove C1212 from the rail, and then measure again to see if our shot is cut. Clearly, we can see that the cap looks funny, and it clearly tells us that the cap itself it's faulty, and that can clearly indicate why we have a short on the PP3 V3 underscore SO. So what we now want to do is to remove that cap from the line, and then see if our short it's going to be cleared out. So that so basically we first thing we need to do is to remove the cap from the rod itself. Now U5611, that is from U5611 we can confirm if we indeed have a short. So we can either measure from the cap, or we can measure at U5611, and indeed we confirm that there is a short on the line. Now the next thing we want to do is to remove the cap from the line and then see if we still have a short. Of most of the time, what will happen is when you have a cap that looks this funny, with the cap out of the line, you should have your short should be cleared out, and you should have a working circuitry. So right now we just trying to remove the cap from the line, and then we take it up from there. So basically, your capacitor, the way it's designed is such that it has two parts. It has a pad, one pad will be connected to ground, it will have an insulator in between it, and then you have another part that will be connected to the main line. Now, when the cap fails, there will be no insulations or no separations between the cap. Then what will happen is whatever is on pad A in terms of pin 1 will be the same thing that you find on pin 2. So now that the cap is out, let's see if we still have a short on the rail. And yes, we still have a short. Yeah, that's not good. We still have a short. Uh, okay, we still have a short on the line. So the next thing we want to do now is to find out what else is connected on that line that could have possibly have been connected. We can confirm that indeed the cap itself it's faulty. Uh, but the next thing we want to do is we want to see what else is connected on that line that may have been affected or that could possibly still be causing the short. Now, uh, yeah, I mean, ideally with the cap out of the line, the short should be out, but the cap is out and we still have a short. So right now we're just looking through the board to see if anything else stands out that may be the reason why we still have a short on our PP3V3 underscore SO rail. Check the other side. Okay. Let's check again. Now let's see if we at least let's see if we have 3.3 volt on that rail. Let's just see. Let's go to voltage mode. Maybe our multimeter might be playing tricks on us. Let's see if we have a 3.3 volt. Okay, let's confirm that we are in SO rail. As you know, our practice is we usually like to have our fan disconnected. We like the multimeter to tell us the state that we are in. Yes, we're still in SO. Now let's see if we have a 3.3 volt and SO line. Let's see if we have 3.3 volt on the line. And nope, there is no 3.3 volt. So indeed we still have a short on that line. So the next thing we want to do, first and first, disconnect the charger from the board, and we want to see what else could have been shorted. Now we just hope that the CPU has not been affected. Yeah, we hope the CPU has not been affected. Um, yeah, let's hope the CPU has not been affected. Okay. Let's open up the schematic, get an idea of exactly what is happening. So um we what we want to do is we want to see where the rail it's being created, where the PP3V3 is generated from. We want to troubleshoot the line from there. Yes, we know the cap itself. So what we want to do is we want to search. So that's yeah. Now we basically, so what we are doing is we wanna trace it. We wanna do a back trace. So we search for U5611. Now at U5611, what we wanna see is we see that PP3V3 underscore SO is going into it. What we wanna do is we wanna copy PP3V3 SO and then search to see where it's being created from. Now this is where it's going into. Okay, so that's not where it's being created from. We need to, so what we're looking for is where pp3v3 underscore so it's being generated from. So let's go to the next page. And now it's not being created from here. Okay, next page. Next page. Next page. Next page. Okay, that's it's now being created from here. Let's go to next page. Next page. Next page. Okay, let's go to all of this. This is not where it's been generated. We have to keep going until we see where pp3v3 underscore so is being generated. That will be where we intend to be. It's not being generated at this page. Let's go to next. Not at this page. Not at this page. Not at this page. Not at this page. This is not at this page. This is 3.3 S3 SDS. No, not at this page. We have to keep going. Let's keep going. Not here, not here, not here. Let's keep going. Keep going. It's current sensing. Not here, not here. This is the sensor page, not here. No, that's no, not here. Okay. Oh, by the way, here we can clearly see because the pp3v3 underscore so rel is required uh, for the fan control. It plays a role in the fan control. That is why the fan go crazy, because it just spins at full speed without any form of control. So this is it's clearly because pp3v3 underscore so rel is not present at that section. That's why the fan go crazy. That's just by the way. So the what we want is we want to see where the rail is being generated from. Here, this is where it's coming into a secretary. We're not looking to see where it's coming into a secretary. We want to see where it's being generated from. So let's pp3v3 underscore so. We're trying to see where the rail is generated. Okay, once again, just to confirm that we do have short on the pp3v3 underscore SORL. Let's go back to our board view. And we can measure that on U5611, which is this here. Black over brown, and black over here. Yes, we do have a short there. So the next thing we want to do, we are basically trying to say where the real itself is generated. So when we see all of this, we see, for example, here pp3v3 underscore so is present here, but this is not where it's generated. We want to see where the real itself is generated, which is why we have to copy and paste the line on our search. Okay, so here it says pp3. Okay, yeah. So this is where, so here it says so it says 3.3 volt SO switch. So this is where the rail itself is generated. It's generated at U8030. So U8030, let's go back and say search for U8030. U8030 search. Okay, this is U8030 here. This is where our 3.3 volt is being generated, and we are not worried about here. So usually the way this will work, for example, if we come here, so U8030 has so this is the this is the voltage in, V in, that is the voltage in. So in order for U8030 to function, it needs PP3V3 underscore S5. We're not worried about this. Also, in order for this to function, which is in order for it to output, so we have V in and V out. Now, in order for this in order for our V out to come to light, it needs the enable signal here, which says here on. Now, this is obviously, so this and this will be required, power to the chip, and then also to tell the chip to basically to turn on. So, and then if this is present, the voltage here is present, and the enable signal here is present, then you will get your output. Now, we're not really worried about if this and this are present, because definitely this and this are going to be present. What we're worried about is the output line here. There's a short on this output line. So first thing first, we did identify that our primary cause of the voltage, the short on that voltage was C. Let's just go back to, so was C1212. This was a capacitor that had issue, which is this capacitor here. So this cap here was shorted. It's just so you see that cap was shorted, and the cap was obviously behaving like a wire. Let's put them down. So that is the cap that was shorted. That was the beginning of the short on the line. However, even though the cap is out of the line, there's still a short. Now, my fear is I am hoping that the CPU, which is obviously the PCH, which happens to be part of the CPU, this small section here, that's going to be the PCH. Now, I'm hoping that the PCH has not been affected um, from the effect of the short on the PP3 V3 underscore SOL. So we have identified, so just go back to that. So U8030 is gonna, it's the chip that outputs 3.3 volt, which is this U8030. This is the chip that basically outputs the PP, that this is that regulates the 3.3 volt SOL. So that chip is going to be this one here. This one here. Uh,
Can we ask questions?
yeah, you can.
I was just saying the way we're measuring that chip now out of the board. I see that where was serving as ground.
Say
Correct.
again.
I saw you were measuring for shots on the chip itself,
Mm-hmm.
but there was no ground.
Yeah, so because it's a capacitor, when I do this, when I put my black probe and red probe together on both sides of it, it should not beep because it's not a fuse.
Okay.
You
Okay.
understand? If it beeps, it tells me that A and B are one.
Connected together. Oh, okay.
Because if A and B is connected together, it means ground will be connected to main.
To me, yeah. I didn't see the probe. I thought you just put the ground probe on top of the chip itself and the measuring probe on the side of the chip.
Oh, okay. So so now we are not worried about U8030. What we are going to be worried about. Another thing we can do is we can, so if you look at this point here, U8030 is going to be generated from R54 5440, obviously from pin 1 and 2 of U8030. So what we want to do is it is not likely, but let us remove U8030. It is not likely that U8030 has become faulty. However, let's remove U8030. Okay, U8030 is out of the line. Now, with U8030 out of the line, so we say Pin 6 of U8030 is going to be the enable signal. Pin 4, pin 2 and 4 is going to be the input voltage for U8030 to then produce 3.3 volt SO, which is when the device is on. Now we have a short here, which is then what will then transpire here, and then obviously goes to the rest of the board. Now let's just see if our short is still there. We can measure for that. We can check here for our short. Can you see from there? What can you see?
Here on the screen.
Why would you be here when I'm here?
Just describe it. So I was waiting for the meter readings.
So we can check for 33 underscore so here. And then outside. Let's check our ground. Okay. Okay, let's check again. And then let's check here. Okay. Uh, the short is gone. This is not. This is very good because my fear was that C1212 when it became shorted, it could have basically affected our PCH. But thank God, Alhamdulillah, that's not the case. C1212. So what basically happened was C1212 um, shorted and then it died, and then it then basically affected the regulator itself, which is U where is it U8030. Aha, so which is U8030 here. And oftentimes it wouldn't be the case, but in this particular case, U8030 was also affected, and that was why we had the short. So the next thing we want to do is we want to basically repair that section in terms of having to, and then we can replace it. So while the solenoid is getting hot, let's grab another one from Modulo box. By the way, if you take a closer look, you will see that U8030 has a small dot towards the edge, the right hand side, the top of the right hand side. That that tells you that that is the pin 1 of it. So also if you check here, you see the red dot here tells you that that is a pin 1. When you're replacing it, you have to be aware of the orientation to make sure pin 1 goes to 1 of the chip. Okay. What's that?
And if you remove it, is it necessary to put like
This one. Now, but we can just put it back. Can put it back. Screen passport. Okay, so the carpet's back. Now, in order for us to confirm that, okay, first let's just be sure that we don't have. So another thing you guys should always do is so this chip U8030 is connected to how many lines? How many lines is it connected to on the board? It's pin 5 is one line, that is ground. Now pin 3 and 2, pin 1 and 3 it's 1, which is the output of the line. And then pin 2 and 4 it's 1. Yeah? And then this pin is also 1. So you have one, 2, 3, 4 lines. Yeah? Even though there are 6, because 2 and 4 the same, 1 and 3 the same, 6 stands alone, and then ground stands alone. So if I want to, now underneath the chip, just to confirm that I don't, there has been no bridge between pin 3 and 5, I can measure, I can check that my PP3V3 SO is not shorted to ground. Yes, so that, I mean, that will tell me if this pin and this pin are now connected. So let's see that. Okay, we don't have a short there, and I was basically measuring here at the R5440. So we don't have a short, we don't have a short basically. Now, in order for us to confirm that indeed it's working now, first thing we want to do is we want to say if you are in SO state. Let's first confirm if we are in SO state. The fan is disconnected. We don't want the fan to tell us what's happening. Let us check at the 5-volt inductor here, which is L7520. 5-volt here will tell us that we are in SO state here, this inductor here. So let's see. Switch back to voltage mode, back into ground, here. Okay, 5 volts. So it tells you that the machine is actually starting. Now let's see if our 3.3 volt is now being created. SO, PP3V3 underscore SO. Here, let's see what we get there. Okay, that's 3.3 volts. So at this point now, the machine should be working the way it should. Initially, the fan will start at max initially. The machine is not going to post. There will be nothing. But now that that has been addressed, let's now see if it's the 11 inch screen. So let's now see if the fan will start the way it should start. And then also let's see if we have display, which obviously uh, once you get display, automatically it tells you that the machine is it's posted. So let's see. And now the fan is started. Initially the fan will start at full blast, but now it's no longer doing that. So this is how we should start. So it should start in a gradual process, and then that is it. We have an Apple logo. So before now, the fan will just start at full speed, but nothing will happen, and that's about it. The fan will only spin. There is no form of communication whatsoever. Just see that. So that is, yeah. So the machine was not posting. There was no display. There was no time. Nothing. So we basically we had the damaged cap on the PP3V3 SO line, which is a C1212. C1212 eventually affected with the U8030, so we replaced C1212, and then we had to trace it back. So see what we were doing when we were here, we were basically, when we were searching, we were going, see here it says found on 30 pages. So we were going to places where we found PP3V3 SO signal. However, our goal was we wanted to get to where it's being generated, which is why we came here, and then which led us to U8030. So and then also sometimes if you want to know how this particular component operate, you can copy this ID here, TPS 22924, and then you can get a what is it called? You can get a data sheet for U8030 basically, and then you get a better idea of how that chip itself, how it functions, and other applications where it can be used. Now this repair is complete, guys, and then we will see you guys in the next one. So this is going to be cleaned out. The necessity test will be done. The device will be assembled, and the client can can collect their device. I was pretty much skeptical about this to the CPU, but apparently that really didn't do much damage to it. This is a 2017 MacBook Air. Um, the owner was saying to me that this is an old machine, but that's just a way of trying to downside the price. Telling you, oh, these are old machines. 2017 old machine. I mean, the same amount of time you take to fix an old machine, the same amount of time you take to fix a new machine. I mean, if it's old, I mean, but I just get he's just saying that just because he doesn't want to pay much for the event. Anyway, thank you guys. I'll see you in the next one. Either you didn't have